Hello everyone, we are going to do 4.4 exponential and logarithmic equations today. This section does a really good job of separating the two types of equations that we're going to do. First we'll do the exponential and then we'll do the logarithmic. The best part is for exponential you use logs to solve, for logarithmic you're going to use exponents to solve. Usually, most of the time. There is one exception, but other than that, you will. Alright, so check point 1. This one's solving an exponential when you can have like bases. This is actually your exception. And the reason it's an exception is because you usually can't make like bases. So when you can make like bases. Alright, so we have two examples for this one. We have A and we have B. For A, we have 5 to the 3x minus 6 equaling 125. And then for problem B, we're going to solve 8 to the x plus 2 equals 4 to the x minus 3. Alright, so looking at problem A first. Looking at the bases. Now the thing that's different about these is you do have the x and the exponent. The x is up in the air. So we got to do something to bring it down, basically. So the 5 and the 125 can have the same base, which would be 5. Because 5 to the third power is 125. This side already has a 5 as its base. So if 5 to the 3x minus 6 equals 5 to the third, then we can just set the powers, or the exponents, equal to each other. So 3x minus 6 equals 3. So 3x equals 9. Divide both sides by 3 and you get that x equals 3. And that's your answer. Problem B, we have a similar situation. Our bases are 8 and 4. The thing that's a little bit different is you can't raise 4 to a power to get 8, like we could with the 5 and the 125. But we can raise 2 to a power to get 8 and 2 to a power and get 4. So we'll go about this that way. So 8 is 2 to the third. And 4 is 2 to the second. Then I'm going to take those powers and multiply them times whatever was already there. So this will be 3 times x plus 2. This is 2 times x minus 3. So now we can just set that denominator equal to each other. So 3 times x plus 2 equals 2 times x minus 3. Distribute the 3, you have 3x plus 6. Distribute the 2, you have 2x minus 6. Subtract the 2x, that'll just be x plus 6 equaling negative x. Subtract the 6 over here, you'll get x equals negative 12. And that will be the final answer. So those two were examples of ones where you can make like bases. Checkpoint 2 will not have that situation. So checkpoint 2 is to solve an exponential equation. When you cannot make like bases. For problem A, we have 5 to the x equals 134. So we cannot raise 5 to a power to get 124. So we're going to have to use logs. Logs are what help you to bring the x's down. So we can do, and you can use log or regular log or natural log, it doesn't matter. So if I do natural log of 5x, 5 to the x, equals the natural log of 134, then using the rules that we learned in 4.3, the x can come down in front. So you'd have x times the natural log of 5 equals the natural log of 134. And you want the x by itself, so divide both sides by natural log of 5. So x equals the natural log of 134 over the natural log of 5. That would be the exact answer. To get the approximate answer, let's see, natural log 134 divide by natural log of 5, you get 3.04. So this is approximate. This would be exact because it's not rounded. Okay, so sometimes the directions might say to answer it one way or the other, sometimes they don't. So you just have to read the directions and see what it has you do. All right, for B, it has 10 to the x equals 8,000. Now here's the thing about a base of 10. Base of 10 is your common logs. So I would use common logs for this instead of natural logs because you can do a little shortcut. So you have the log of 10 to the x equals the log of 8,000. And the log of 10 to the x, that's 10 to what power is 10 to the x? So really that's just x. You can bring the x down in front and then this equals 1 if you want. Or just know that that kind of cancels out. X equals the log of 8,000. That would be your exact answer. For your approximate answer on this one, you could just type in regular log and then 8,000 and you get 3.903. And that's your approximate one. Okay, so let's everything we've done so far, the base to the power has been by itself. So like 5 to the x, 10 to the x, it's on a side by itself. We were able to just take the log of both sides right off the get-go. Checkpoint 3 will not be that way. We're going to have to get the base to the power by itself first. So always look for that. Look to make sure you have a base to the power by itself first. So checkpoint 3 is solve an exponential equation. Get the base to the exponent by itself first. All right, so for this one we have 7e to the 2x minus 5 equals 58. All right, so our base to the exponent is e to the 2x, which tells me I'm probably going to want to use natural log when the time comes. But this is not the time yet. because you need to get the e to the x by itself first, which means we need to move the 5 over. So 7e to the 2x equals, and then this would be 63. Divide both sides by 7, so e to the 2x equals 9. And now we have the base to the power by itself, so now we can take the natural log of both sides. So the natural log of e to the 2x equals the natural log of 9. Don't forget to do both sides. People do forget to do that. They'll just do one side or the other. Natural log of e basically crosses out, or it equals 1. So this would be 2x equals the natural log of 9, but we're not solving for 2x, we're solving for x. So you do need to divide by 2. So you have the natural log of 9 divided by 2, which would be the exact answer. This one, I believe, actually tells you to put it in decimal. So either way, just be prepared to do either one that the directions ask. So natural log of 9, make sure you close the parentheses, then divide by 2. Otherwise, you'll be dividing by, like you're taking the natural log of 9 divided by 2. Okay, so we get x to be approximately, and that's 1.099. And that's our rounded answer for that one. All right, checkpoint 4 and checkpoint 5 are two of the harder ones, I think. Checkpoint 4, we're going to have x on the exponent on both sides. Alright, so checkpoint 4, we're going to solve an exponential with exponents on both sides. Alright, for this one, dang it, I should have done this. Hang on. Let me just pull out another piece of paper. This one takes some space. Okay, we have 3 to the 2x minus 1. Equals 7 to the x plus 1. Alright, so we already have the base to the powers by themselves. So we already have that part set up. So we just need to get them down. We need to be able to pull the x's down in front. So you're going to take the log or the natural log of both sides. I like to use natural log only because it's 2 letters instead of 3. No, it doesn't really matter. So take the log of both sides. Now you're going to bring that entire exponent down in front. So it's times 2x minus 1 times the natural log of 3 equals x plus 1 times the natural log of 7. Alright, so we need to get our x's together. So first I'm going to distribute our natural log into the parentheses. So the first one we have 2, let me make it 2 natural log of 3 because that's all a number, times x minus, and then natural log of 3 times 1 is just natural log of 3 equals, then we'll have the natural log of 7 times x plus, and then natural log of 7. Alright, so like I said, we want to get those x's together. So I'm going to move this one to the left, and I'll move the natural log of 3 to the right so it's on the other side. So just moving stuff around, you have 2 times the natural log of 3 times x. Now minus the natural log of 7 times x. Actually, I should do that. so it doesn't look like that x is in the natural log, because it's not. Probably should have put the x in the front. Equals natural log of 7 plus the natural log of 3. So what I can do now on that left-hand side is factor out an x. So we have x times 2 natural log of 3 minus natural log of 7 equals the natural log of 7 plus the natural log of 3. Now, we're going to have to put all this in our calculators and divide to get x. You can do that from here if you want. Just put this in the calculator, divide by this. Or use some rules and make it a little bit simpler. Plus, it's just a good review. So this could be 3 to the 2 minus natural log of 7 equals, and this is 2 logs with a plus. Just multiply them. It's the natural log of 21. So over here we have x times the natural log of 9 minus the natural log of 7. We have 2 logs with a minus, which is division. So x times the natural log of 9 over 7 equals the natural log of 21. Then you can just divide that. So natural log of 21 on the top, natural log of 9 over 7 on the bottom. That's what you very carefully put into your calculator. So natural log of 21, close the parentheses, divide by the natural log of 9 divided by 7. So you get 12.114. Yeah, we'll do 12.114. And that's our answer. Those are rough. They just take up a lot of space. Alright, so checkpoint 5. I'm gonna start new. This one isn't as long. But honestly, this section, 4.4, is the meat of this chapter 4. So if you don't know how to do anything else, you need to know how to do this stuff. However, you have to understand pretty much 4.2 and 4.3 to do well in these. So that's why these end up being a big chunk of what you're going to be tested on. Alright, checkpoint 5. This one's solving an exponential equation also. But we're going to have to use factoring. Okay, we have e to the 2x minus 8e to the x plus 7 equals 0. Alright, I'm going to go to the side real quick and do another problem that's kind of like this one. This is very much like the problem x squared minus 8x plus 7 equals 0. It's solved the same way, because if you did x times x, you would get x squared. Just like e to the x times e to the x would actually be e to the 2x. Alright, so we need two numbers that multiply to get to 7 and add to get to negative 8. So we would make two parentheses, both starting with x, and then multiplies to 7 and adds to negative 8. That's negative 1 and negative 7. You would set both of those equal to 0. And then you would solve them and get x is 1 and x is 7. Alright, but this is just our thought bubble on a similar type of problem. Now let's take it up a notch. This one has an e to the 2x, and then it has an e to the x in the middle. Notice this one uses the x here, and then, or the x is in the middle, and then that's what goes here and here. Same deal if you have a hard time remembering. So e to the x is what's going to go in the middle, in the front, because e to the x times e to the x is e to the 2x. And then I need two numbers that multiply to 7, add to -8. That's -1 and -7. Then we do the same process. Set each of these parentheses equal to 0. So e to the x minus 1 equals 0. E to the x minus 7 equals 0. So e to the x equals 1 and e to the x equals 7. But that's not what we want. We want the natural log. We want to know what x equals. So I'm going to take the natural log of both sides. Natural log of e to the x will just be x. So x equals the natural log of 1. That's e to what power is 1, which would be the 0 power. If you're not sure, you can always use your calculator and just do the natural log of 1, and you get 0. So this one's nice. It works out nicely. You get x is 0. This one, taking the natural log of both sides, you get x equals the natural log of 7. Not as nice of a number, but as long as you have a calculator, you can just enter it. You get 1.946. And there's your two answers. Just like that problem has two answers, so does this one. Alright, so that is the end of exponentials. And hopefully you see what I mean by the fact that you use logs to solve an exponential. That's how you bring the x's down. Alright, so now let's get into some logarithmic ones. We'll start with checkpoint 6. This one's solving a pretty basic logarithmic equation. Oh, hang on. Before I do that, anytime you do a problem with a log in it, you have to check your answer. So when you solve an equation with a log in the problem, you must check your answer to see if it will fit in the domain. Okay, so in doing that, you remember you can't take the log of a negative number or 0. All right, now we'll do checkpoint 6. I'm gonna start a new piece of paper, just in case I don't have quite enough space. Okay, so solve a logarithmic equation. Nothing special yet. Alright, first one we have log base 2 of x minus 4 equals 3. Alright, so this one you have a log by itself on the left hand side. So we can go ahead and get it out of log form by putting it into exponential form. So 2 to the third would equal x minus 4. 2 to the third is 8. Add the 4, so 12 equals x. And that's not enough, you gotta go check it. You don't have to actually check to make sure it works, although you could. But just looking at it, 12 minus 4, that's 8. 8 is okay because it is positive. So this fits into our domain. And also 2 to the third power is 8. So kind of reaffirms that that is our answer. All right, and let's look at problem B. Problem B, we have 4 times the natural log of 3x equals 8. Now, on B, the log is not by itself. So we need to get the natural log by itself first. I do apologize. A lot of times my LNs look like H's. Alright, so we're going to divide both sides by 4. So the natural log of 3x equals 2. And then we got to get it out of log form. But it is a natural log, but that's okay. Our base is just e. So e to the 2 equals 3x. And then to get the x by itself, we're going to divide both sides by 3. So e to the 2 divided by 3 will equal x. That's the exact answer. For the approximate answer, I'm going to go on my calculator, do e to the second power, divide by 3, you get 2.463. Okay. Okay, so those each had just a single log in the question. The next one we do, the question will have 2 logs of it. So we're going to have to put those together. So this will be checkpoint 7. Oop, 9. Solve a logarithmic equation. We have log of x, so that means it's base 10, plus the log of x minus 3 equals 1. So we have 2 logs on one side, but there's not a log on the other side. So just the 2 on the one side. We can put those together. So 2 logs with a plus becomes multiplication. So we have log of x times x minus 3 equals 1. And now we can take it out of log form. Our base is 10. So 10 to the 1 equals x times x minus 3. 10 to the 1, that's 10, equals, this will be x squared, and then minus 3x. Move the 10 over, so 0 equals x squared minus 3x minus 10. Put an x in front of both. 2 numbers that multiply to negative 10 but add to negative 3. That's a negative 5 and a positive 2. Set them both equal to 0. So you get x is 5 and x is -2. Okay, then you have to check them. So looking at what we have, if you plug in 5 here, log of 5, that's fine. 5 minus 3 is 2. Oh, that's fine because it's positive. Now the -2, log of -2 right there is not okay. Now it's not because it's negative. In this case it is, but just if it could be negative, but if something made it positive, it'd be okay. But there's nothing to make it positive, so 5 ends up being your only answer. Okay, because you can't take the log of a negative. Alright, this next one is, like, I want you to try to notice the difference between checkpoint 7 and checkpoint 8. Checkpoint 8 is going to have logs on every single part. So, like, everything on the left and everything on the right. I think I can fit on this page. Okay, so solve a logarithmic equation. Everything has a log. Alright, so we have the natural log of x minus 3 equals the natural log of 7x minus 23 minus the natural log of x plus 1. So everything has a log. So we have 2 logs with a minus on the right hand side. So 2 logs with a minus becomes division. So on the left we have the natural log of x minus 3. On the right will be the natural log of, will be 7x minus 23 and divide by x plus 1. So log of the left, log of the right. We're going to be able to just drop our logs because it's a log of both sides. So we can just do x minus 3 is equal to 7x minus 23 over x plus 1. And now you just solve the algebra problem. So cross multiply. We'll be multiplying x minus 3 times x plus 1 equals 7x minus 23. Foil this, you get x squared. In the outer you get x. Inner you get negative 3x. And then negative 3 times 1 is negative 3. Move everything to one side. So I'm going to subtract 7x from both sides. And I'm going to add 23. We'll do all that at once. So on the left hand side we'll have x squared. 1 minus 3 is negative 2. Negative 2 and negative 7, that's negative 9x. Negative 3 plus 23 is plus 20 equals 0. Factor that out. Two numbers that multiply to get to 20. Add to get to 9. That'd be 4 and 5. So minus 4 and minus 5. Set each of those equal to 0. Oh, I just made it. And you get x is 4 and x is 5. Now when you have two answers, don't assume that one will work and one won't. So we have to check it. Putting in the 4 minus 3, that's 1. Good to go. Putting in 4 here, that'd be 28 minus 23, that's positive 5. Good to go. 4 plus 1 is 5. It's good to go. So x equals 4 is definitely one of our answers. So I'm going to check 5. 5 minus 3 is 2. Perfect. 35 minus 23 is, I don't know, but it's positive. Good to go. 5 plus 1 is 6. It's also good. So this one actually has two answers. x equals 4 and x equals 5 are both correct. Okay, so that's the end of just doing, this is not the end of the section. We're going to have a couple word problems. And one of those word problem types are the like PERT and all that. Just finding different parts than what you were finding before. Alright, so checkpoint 9 is a word problem. And in it we have a formula. That formula is R equals 6e to the 12.77x. Alright, so it says use the formula in example 9 to answer this question. What blood alcohol concentration corresponds to a 7% risk of a car accident? Alright, so example 9 tells us that medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. Alright, so where X is the blood alcohol concentration and R, given as a percent, is the risk of having a car accident. Okay, so X is blood alcohol concentration. And the R is the risk. Alright, so it says, what are we doing? Okay, it says what blood alcohol concentration corresponds to a 7% risk. So we have 7% risk. Our R is 7%. What is X? Basically. Alright, so let's just plug in and solve. So 7 equals 6e to the 12.77, and then X is what we're solving for, and X is up in the air, which means we're going to have to be using logs to solve this. You got to move the 6 first, don't forget. People forget that all the time. So 7 divided by 6 equals e to the 12.77x. I have an e as my base that is now alone. So I'm going to take the natural log of both sides. So the natural log of 7/6 equals the natural log of e to the 12.77x. So natural log of e will cancel out. This will just be 12.77x. Get the x by itself by dividing both sides by 12.77. Alright, so then we need to do that in our calculator. We have the natural log of 7 divided by 6. And divide the answer by 12.77. Get 0.01. So it's a 0.01 blood alcohol concentration. So basically you're just plugging in some numbers and solving it. Alright, now checkpoint 10 is going to use our old formulas. We're going to have something being compounded quarterly. So something being compounded quarterly means that we're not going to use the PERT, because that's like an all the time thing. That's being compounded continuously. So we're not using that one. We're going to use the other one. compound interest formula. Okay, so we'll be using A equals P times 1 plus R over N to the NT. All right, and the problem tells us if I can find it. What the heck? Okay. How long to the nearest tenth of a year? Okay, so that means we're looking for time. Will it take $1,000? That's our P. To grow to $3,600? That's our A. At 8% annual interest. So 8%, which will convert to 0.08. Compounded quarterly, so N equals 4. Alright, so let's plug into our formula. We have 3,600 equals 1,000 times 1 plus 0.08 over 4 to the 4t. Alright, so we got to undo all this. First thing you actually need to do is divide by 1,000. So 3,600 divided by 1,000. We just move the decimal over 3 places, and we get 3.6. It's a nice number. If it wasn't, I would just leave it as a fraction. And then we can actually do this too, but since it's notes, I'll wait a second. Okay, so 0.08 divided by 4, that'll be 2. Or, sorry, 0.02. Add that to 1. So this will be 1.02 to the 4t. That's actually our base. So we right now have the base to the power. So this is the point where you can take the natural log of both sides. So the natural log of 3.6 equals the natural log of 1.02 to the 4t. Or regular log, it doesn't matter. So natural log of 3.6 equals, I'm going to bring this down in front, 4t times the natural log of 1.02 divide by 4 and the natural log of 1.02. So t is approximately, let's see, natural log of 3.6, close the parentheses, divide by, I'm going to start a parenthesis and do 4 natural log of 1.02. We get 16.1, but I think it said around to the nearest year. Oh, tenth of a year. So it'll be 16.2 years. Alright, so that is 4.4. Make sure you know how to do this. If you don't know how to do anything else, make sure you're good on 4.4. And have a great night or day whenever you watch this. Stay safe.